This is a universal joint. It's used in cars, helicopters, and any mechanical engineering application in which an axle needs to maintain rotation around a bend. I think it's a really interesting application of mechanical engineering, a really cool mechanical engineering part. Today, we're going to build one.
So first I'm going to open up Autodesk Inventor Pro. This is the file that I use for all of my computer design models, 3D models for 3D printing or for engineering projects. That's just because I get this software free from my university. The same things that I'm going to show you on Inventor, you could also pretty easily use on SolidWorks or any other type of engineering application. So we're going to go File, New, Standard Part, Create. First things first, I'm going to design the part of the joint that actually holds the axle and rotates around that center piece. I call it the joint holder, personal part title preference. So we're going to go Sketch, Create, Rectangle. Personal preference, I always start on the XY plane. Now I want this to be 100 millimeters by 50 millimeters, but I'm going to start by creating half of the part and then revolving it. So I'm going to start with 100 by 25. And then, like I said, right away we're going to just revolve this piece, go 3D model, create, revolve. Already have this plane selected as profile, axis, the x-axis. Now instead of 360 degrees, I'm going to rotate this 180 degrees. That's because I'm using a 3D printer to manufacture this joint here. When I go to print this out, I'm going to have a hole for the axle coming through here. I need to actually be able to put this piece together around the axle rather than having a hole here and having to feed an axle through here to meet at a joint with a cap on the end. It's going to be a lot easier to be able to assemble this by just printing the whole axle with the cap on the outside and the joint together all as one piece and placing this piece and this mating half around the axle, gluing it and calling it a day. Another reason for that is if this were to be a full cylinder and I go to print this out, one of these curved sides is going to be on the print bed. And when that happens, I'm going to have supports that go all the way across here. This entire face is going to be covered in support structure. Now it's going to be a big problem when I go to try to take the supports off and sand this down. It's going to leave extra material that we don't want. Or we're going to have a lot of sanding that we don't want to do. It's going to be a lot easier to just make this in half and then print 4 of these for the total joint together. So now that we have our half, I'm going to come around to this side, and I'm going to cut out the section here that's going to wrap around and actually have the holes for the axle to hold that joint. So I'm going to go Sketch, Create, Line. I'm going to go right here, and I'm going to start by putting in the lines that's going to mark out the sections here. So first we're going to have 10 millimeters coming down at 90 degrees. And that's going to mark out the section that's going to hold the joint here. So you can imagine if this here that I have my line around is the section coming up, the axle would come through here and the joint core is going to be right here. I'm going to bring this over here 30 millimeters and another 30 millimeters and then up another 30 millimeters. What this does is it creates a nice square for that joint core to come into while producing a full centimeter on either side to actually hold that hole. This way we have thick enough material right here on either side so that we don't really risk significant potential for stress and catastrophic failure around the points that normally would develop a majority of stress. Now, one problem that's going to develop here is stress over time as this part wants to move outward like this or inward like this, really just as a result of stress from repeated rotation. All that stress is going to build up at this point here, and that's going to provide a point of potential failure. Plus, this one square probably isn't going to be as much room as I need. So to kill 2 birds with 1 stone on this one, I'm going to go Sketch, Create, Arc. Make a half circle right here. What that's going to do is it's going to first thinning out this joint cavity here for that extra space for motion. But second, and pretty importantly, this is something that we learn in classes that we typically take in our first or second year in an engineering program, that the stresses that normally will develop center around this one corner, once you put a fillet across that corner, which now of course the corner would be down here, all that stress distributes evenly across this full radius here. This is actually, from an engineering perspective, why you see the roots of a tree come down like this and then do this number, is it spreads the stress out across here in an actually really phenomenal pattern from an engineering perspective. So we have our full cavity here marked out as lines. We're going to draw another line right here to wrap up that sketch. That way we can come and select these two planes and extrude the thing all the way through to cut out that material. So we're going to go 3D model, create, extrude, select both of these profiles, select extrude cut, and then just any large number that's going to completely take care of all of the material there. So now we have a lot of this pretty much done. First, before we're finished, we need to come here and make the half circle for the axle that's going to come through. So I'm going to go sketch, create, line, set right here. And now I know that the hole for the axle is going to go somewhere on this plane, probably closer to here than to here, because wherever the axle goes, the other piece is going to need to come over as much as this section, the whole section, and another one of these sections over. And I need to make sure that these parts don't interfere. So I have a total of 30 millimeters this way. I'm going to make sure that the other part doesn't come further than 25 millimeters, just to make sure I have as much room away from any potential for interference possible. So 25 millimeters, I could say a centimeter, and then half a centimeter for the hole, and then another centimeter to account for this centimeter section that would be on the other piece. But that would produce a really small hole, and when we go to 3D print a piece, we have to account for the potential for any section that's being printed to have material spillover. So an axle that we would be producing to go through a 5 millimeter diameter hole would have to be no more than 3 millimeters in diameter. And that becomes a really, really narrow axle when we start talking about PLA and layers. So what we're going to want to do is actually make sure that there's enough room in this hole, not quite 10 millimeters, because we don't want just a 5 millimeter section here that would produce too much of a risk for failure. Instead, I'm going to make the whole 9 millimeters and then account for 8 millimeters on either side. That still accounts for 25 millimeters, but this way I have a larger hole and I can have an axle much larger than 3 millimeters that still has enough clearance to make sure that there's not going to be any interference when I go to try to put this part together. So I'm going to come out here, 8 millimeters, 9 millimeters, and now I'm going to go create arc, make a half circle at 4.5 millimeter radius, and then 3D model, create, extrude, and we're going to cut this section out just like we cut the last section out, except now I'm going to do a two-way cut so that I can have this hole on both sides. And to make that 100 millimeter extrusion, make sure I absolutely take care of every bit of material that I really want to get out of here. It's okay to go overkill on the distance that you're extrude cutting, because all it's doing is making sure that you're cutting out the material. I could go, 10,000 millimeters. It's still cutting out the same material. So now we have this section cut out. The one thing we have left to do is going to be to smooth this out and really cut out a lot of this section. The reason being, and I printed out pieces to display this, is when we take two parts that are printed out just like we see here and try to put them together as a joint, it winds up not working because they come out to interfere. The reason being, this part is 50 millimeters, well this is half size, so this part is 25 millimeters from here to here, but only 15 millimeters from here to here. But that 25 millimeters on either side here, or 50 in the case of the design, has to fit inside that 30 millimeters, or 25 inside this 15. This outer side is way too big for this, and even though you can see it kind of comes in, right, so it wouldn't be the full 50, it's still between 30 and 50 trying to fit in 30. So that's always going to interfere. It's never going to work. So we need to cut out the excess material right here. To do that, since I know that at this axle hole, both parts are going to have an axle hole, and then the other part is going to come an additional 8 millimeters over this way, I'm going to go ahead and decide that since I have 30 millimeters of distance this way, I want some extra room on either side to make absolutely certain that they aren't going to interfere. So I'm going to leave some extra space on either side of this. So instead of making this 30 millimeters, I'm going to make this 24 millimeters. That way I have a full 3 millimeters on either side between each part. So to make sure that happens, I'm going to go create line, and I'm going to work on this plane. I'm going to come right here to the edge of this axle hole. I'm going to come up half of that 24 millimeter distance, go 12 millimeters, and I'm going to go create arc, going to come from the end of this line to the end of this part and produce an arc. Now, I want this to flow about like this, about in an S shape. So I can't have this arc coming out like this. I can't have it like this because then I have a straight line. It's too thin right here, and it just doesn't look good. So I'm going to right around here. Reasoning is it's coming almost to parallel right when it meets the line. That way, when I go to produce another arc from here to here, it's going to be a lot easier to make this an arc that meets that first arc tangentially. And Autodesk Inventor does a really cool thing where it actually shows you when the arcs are meeting tangentially right here when you see that circle meeting a line. So now we have two arcs, and we can go ahead and check here that they are in fact meeting nice and smoothly. The reason I'm doing that is mostly for aesthetic preferences. I don't want a jarring edge between the two arcs, but that's also for making it easier on my printer to not have to produce that hard edge, and also to mitigate any potential for any extra stress accumulation at an edge or for those edges to potentially butt against each other. So we're making as smooth a shape as possible. Then to extrude anything, we have to have a wrapped up sketch. So I'm going to go line out to here, line out to here. Now I have a completely enclosed sketch. Now I can go create, extrude, select this full plane, extrude cut, two ways so I can take care of all of it right at once, and select OK. Now this is almost finished, but now you can see we have these flat planes. I don't like that. Partly it just looks ugly, but another reason is this in here can produce another point of risk for those parts to interfere. I don't want to have done all this work to cut out this extra material and then wind up with these edges ramming right into each other. So I'm going to produce a fillet across here. That way when the pieces come together, they're going to curve away from each other. I'm going to go 3D model, modify, fillet. Then I'm going to select these edges here. And I'm going to produce as big of a fillet as I can get away with on this edge. So let's try 6 millimeters. Okay, so when it shows a line like this, that means that the radius I put in is too big for that edge. So I'm going to bring it down, let's just say to 5 millimeters. And we can make that fillet, so we're going to go ahead and do it. Now, like I said earlier, this is going to make sure that the parts curve away from each other actively. And then just to round this out, make it look a little nicer, make the assembly smoother at the end of the day, I'm going to put another fillet right on these edges. It's going to be a much smaller fillet, especially since I can't have a 5 millimeter fillet right there. This one's going to be about 2 millimeters. Apply. And now we're done with this part entirely. We'll be printing 4 of these to make the total joint. Next, we're going to move on to designing that joint core. Let's get to it. We're going to go File, New Part, just like last time. And also just like last time, we're going to go to Sketch, Create, Rectangle, and start on the XY plane. Except this time, we need to make a part that's going to fit inside the cavity left by the joint holder pieces. So we have 30 millimeters in one direction, 30 millimeters in the other direction of total space. Now, whatever joint core we design, we do not want it to fill all 30 millimeters because that's going to cause some really rough interference and it's just not going to work. So I'm going to make sure that this has plenty of clearance to it. And I'm going to start with a 20 millimeter by 20 millimeter square. This produces 5 millimeters in all directions to make sure that I have as much clearance on this part as possible. So then we're going to go to 3D model, create, and extrude. Let's bring it out about 15 millimeters. I'm not bringing it out a full 20 because we don't need this to be a full cube, and I only need an axle out of these faces, and these faces can be blank, and I don't need a full 20 millimeter width for the faces that the axles are coming out of because I'm not making a 20 millimeter wide axle. Even the axle base that we're going to make that's going to be there to reduce stress accumulation from that flat edge doesn't need to be a full 20 millimeters wide. So let's leave it there. All right, then we're going to go sketch. We're actually going to start with the line because even though the axle and the axle base are both going to be cylinders, we have to start from the center of the face. So we're going to use a line to go ahead and find that center. Now we can also use this work tool placing a point on the center of this face. Both are plenty fine as long as you're not doing way too many steps to do one way when you could do it another way with way less steps, but this becomes about the same number of steps either way. So bring it up 10 millimeters and another line out here, 7.5 millimeters, and voila, we have our center of the face. We can go create circle. Now, with this circle, we're making the profile of the axle base, not the whole axle. So we're going to go ahead and actually make this a full 15 millimeters in diameter. And then when we go to extrude this, so I have to remember, I have 5 millimeters of total space, not including any tolerances between this face and the end of the joint cavity space. So I need the axle really to start before that to account for any event of any 3D printer extrusion mistake or material spillover or anything like that. I need some extra clearance for that. So I'm going to bring this out 2 millimeters. That's going to make sure I have 3 millimeters of extra space in all directions to really make sure that I never have any interference between these parts. So I'm going to make the profile for the axle itself and then extrude it out into the axle. So I'm going to go create circle right on this plane. Now here I have to remember I made the axle hole 9 millimeters across. I need plenty of clearance between this axle and the axle hole, but not so much clearance that I make an axle that's too thin to function without breaking. So I'm going to make this axle 6 millimeters across. That means I have 1.5 millimeters in every direction while having an axle that's not going to be so thin it's going to snap the first time I try to rotate this joint. So next I'm going to go 3D model, create, extrude out from this circle. Now I have 3 millimeters between the face of this flat cylinder right here until the start of the axle hole. So I need at least 3 millimeters extra length on this axle. Then I have 10 millimeters of axle hole, so I need at least another 10 millimeters on the axle. But I need an axle cap at the end to be wider than the hole to make sure that the axle doesn't slide out of the hole at any point during operation. And I want the same clearance on that side as I have on this side. So I'm going to go ahead and make this axle 15 millimeters long. That's going to provide 3 millimeters clearance on the inside, 2 millimeters of clearance on the outside before I add that cap. That's going to make sure that no matter what happens with the printer, unless it's a complete malfunction, and I would have to reprint anyways, this part is going to work and the joint is going to rotate at all positions that it's capable to bend to. Now I'm going to make the profile for that joint cap I was just talking about. It's the same deal. Pop a circle at the end of this cylinder, except this time I'm not going to make it quite as wide as this. I'm going to make it wider than the axle. I need to make it wider than 9 millimeters because 9 millimeters is the width of the hole. Should probably make it wider than 10 too. I'm going to make this 12 millimeters across. That way I have 1.5 millimeters on either side in all directions between the outside edge of the hole and the outside edge of the cap. That's going to make sure that this cap is going to hold the axle into the hole, but it's not so far out that the cap might have more leverage and break off of the axle, or the cap might wind up interfering with the joint, anything like that. So I'm going to take this and I'm going to extrude this out 3 millimeters, just to make sure I have some material at the end of the cap there. Next, I want to round off a lot of this. The reason I want to do that is on these inside edges, I want to round them off to reduce that stress accumulation at that single edge. On this side, I want to round this edge out because I want to make sure that this is smooth and as tucked away as possible so that it doesn't interfere with the motion of the joint. Because remember, this will be on the outside of the joint hole, which on one piece is going to be on the inside of the joint cavity on the other piece. So I need this edge to be rounded out for that reason. I also want to go ahead and round this edge out, mostly for aesthetic purposes. I just don't like the look of a flat shape there. And it's also going to make it a little bit easier on the printer to be able to make a round shape here versus a flat edge when we actually go to print this part out. So I'm going to go 3D model, modify, fillet. So I'm going to start with this outside edge. I'm going to select this, produce a 3 millimeter fillet. That's going to bring that curve all the way to the base of this cap, make it as smooth and tucked in as possible. Now I'm going to select this edge and I'm going to produce a 2 millimeter fillet. We're going to have a nice smooth rounded off part. Then I'm going to go to these internal edges here. And I'm also going to make a 2 millimeter fillet. Justification for that is I have a 3 millimeter clearance here. a 2 millimeter clearance here, and a 1.5 millimeter clearance this way. So we don't actually get to a point where this could possibly interfere with this until we get right about to here, further up than half the radius for this fillet. So we won't actually wind up with potential for interference here. Instead, we'll wind up with a nice curve here that if it touches that edge of the joint holder, it'll just produce essentially rolling bearing without the lubricant for this to glide across. So I'm going to go ahead and select OK because we've finished all the fillets that we need for this section. Now, I have one full axle, but I need 4 of these, and I don't want to do this all again. Partly because I just don't want to do it all again, but also because it's possible for me to produce something on this side, or on this side, or on this side that's a little bit different than this axle, and I need them all to be the same as much as I can possibly manage. So I'm going to use pattern, circular, and I'm going to select the entire thing, make sure the entire thing rotates, and I need to select an axis of rotation. Now I want to rotate this about the center of this face right here. Problem is, I don't have an axis of rotation, so we got to fix that. Let's go to Work Feature, select Axis, and then we can produce all kinds of axes. We can make just an axis that'll come out from wherever we click. We can make one from a line or an edge. We have all these lines and edges, but we want it to come out from the center. So what looks really good to me is normal to plane through point. That sounds awesome. We want it out from this plane, but we want this to come through a point in the center, and we don't have one of those. So let's go back to Work Feature, Point. We need a point right in the center. So center point of loop edges. That sounds great. Let's center that point to this face, these edges. Sweet. Now we have this point right here to produce our axis from. We can go normal to plane through point. So at this point on this plane.
And bada bing, bada boom, now we have ourselves an axis. So now I'm going to go back to pattern, click circular, all faces. For axis of rotation, we're going to use the axis that we just made. Now the default setting for a circular pattern is 6 repetitions around 360 degrees. We do want 360 degrees, but we don't want 6. We only want 4 axles. So it's going to place that at 4, and there we go. So next we're going to put fillets along the remaining flat edges, and then cut this in half so that we have a flat face to lay on the printer bed, and then we'll be done with this part. So first I'm going to go to Modify, Fillet, and get these 4 edges. Click OK. Then we're going to go Modify, Fillet, and get all of these edges. And now this is fun. We only actually have to do these 4 because the other ones we're cutting off. Go ahead and click OK. That'll get out of the way. And now we have a rounded out part. Now we just need to cut this in half so we have a nice flat face for that printer bed so that we don't have to have any extra supports for these caps, for the axle, for the rounded bit, sand stuff off. We don't want to do any of that. We're going to cut this in half and print 2, glue them together, and then we'll be set. So to do that, we're going to go Sketch, Create Rectangle, click this plane, and I'm going to draw a rectangle that's going to include the whole half of this that we're cutting off. That's this right half, because remember, we didn't fillet this side. That's because we don't want this side. So I'm going to make a rectangle to cover this entire half. And then I'm going to extrude cut the entire thing. So I'm going to go 3D model, create, extrude, click our face, make sure it covers the full rectangles. See, that's something you might have happen where Inventor recognizes that there is a quarter circle right here that is intersecting the rectangle, and it might try to click everything outside of that quarter circle. But we want this entire half. We don't want any piece sticking out the side. So then we're going to go extrude cut this whole half off, and there we go. Now we have a completed half of the joint square. We're going to print 2 of these for the joint holders, scrape it up, assemble the part. So now I have all the joint holder parts loaded up into my Ultimaker Cura 3D printed file rendering software. And I'm doing 2 things that are pretty important here. First, I'm printing the joint in 2 prints. The first one is going to be all the joint holder pieces that you see here. And the second one is going to be the 2 joint square pieces. The reason for this is I have 2 different colors of filament that I want to use for this project. So I'm going to print the joint holders in white and then the joint square in blue. That way the joint square will be bold against the joint holder pieces and I'll be able to see the parts moving around as I use this joint. The second thing I'm doing is I'm printing this at half size so that this can fit on my printer. When I bring this in at full size, it's 100 millimeters this way and 50 millimeters this way. Well, my whole bed is 100 millimeters by 100 millimeters, so that one part would fill up this entire section remaining here. This way, I can print the thing at half size. It's a plenty big enough size, honestly, for the fully assembled universal joint. So half size for me. If you have a larger printer or if you want to wait while each part prints on its own, feel free to print this larger or feel free to print this even smaller if you prefer. One of the points of this as universal joint is that it can be used for multiple applications and be sized according to the project that you're working on. So now I have the joint square, both pieces loaded up to print. I'm going to port this over to the printer and get it set up. Now I have everything printed out and it's time to assemble. First we have to sand out everything. That means all the flat faces that are going to be joining together as well as the holes that will be receiving the axle. And here I'm using a round file as well as a flat file to get those holes down with the round file and get the flat faces down with the flat file. That also includes those corners you can see me filing down here. It's really making sure that everything is going to work and assemble as smoothly as possible. Sanding down all the parts. Next, I'm going to start gluing it together. I'm using this liquid concrete for plastic adhesion. I find it to be a really solid glue for plastic assemblies like this one. So I'm starting by gluing together the joint square itself. That's because this thing is going to have to come together and then the joint holders are going to glue together around the axles created by this joint square when I glue it together. Now that it's dry, I'm getting my wood burner here and I'm doing what I like to call plastic welding, where really I'm taking advantage of the fact that the method of manufacturing of a 3D printer is to melt plastic and apply it to other plastic. So now I'm taking what is layered melted plastic and I'm melting it together so that as far as the material is concerned, there's not really any distinction between the two parts that were 3D printed and the conjoining faces that are now melted together, just like they were in the 3D printer. Now, anyone who knows anything about welding will know this is nothing like most welding applications, but it's still fun to call it plastic welding, so that's what I call it. We're doing all the outside edges with this. Really make sure that everything is fused together as much as possible without compromising any of the structure and the integrity of the actual piece. So I'm going around all the edges here, making sure everything is put together nicely and smoothly and cleanly before I go and assemble the joint holders around the joint square. It dries really quickly, as you can see there. So now we've got the joint holders, and we're going to place this around the axle, starting with the first one. Now, the benefit of the way that I printed this is being shown now in the assembly, is I can take those joint holders and simply place them around the axle, and the cap is already on the outside, and we don't have to bother with a bunch of tiny pieces being assembled. So I'm starting with a couple dots of glue. I'm going to assemble this just like I showed you with placing this around the axle. I'm going to hold this together and really just clamp it with my own fingers while the glue that's in there, putting it together, dries. Making sure, of course, that the axle can move freely and there isn't any glue or melted plastic keeping it from moving around as I'm assembling this part. Now that the glue is dried, I'm going to come around and do the exact same thing with the wood burner on the outside of this joint holder. Going around the edges, going across the seams, these large seams on the outside, as well as where they meet at the base here, and even on the inside where I made that space for an axle to come into. And I'm being very careful to make sure that I melt the plastic together, but I don't stab into the plastic with the wood burner and melt a hole into the plastic or anything like that. Going around all the edges and lightly touching it with this wood burner to melt the plastic together just enough that the pieces form a strong cohesion and stay together. Now you can see I've plastic welded all of these seams together and the part is holding together pretty nicely. So now we're going to do the exact same thing as we did with those two joint holders with the other two joint holders around the other axle. So we take the joint holder, set it, go ahead and apply those dots of glue, then place the other joint holder right around that with the axle, making sure that the axle is still inside the axle hole. And again, we need to make sure that the axle can move around inside the axle holes that we've made for it. In this particular piece, there was a little bit of a printing mess up on the print bed where there's just a small indent in the seam where those were supposed to join together so that at that point they weren't actually touching. So I went ahead and filled that in with some glue just to make sure it stays together. Now we're going to come around those edges, make sure everything is aligned properly, just making sure that this is coming together and that the pieces are melding together really nicely and aren't going to come apart after repeated use. And again, exactly as we did on the other side, we're coming around here and melting all the seams together. Now we have a completed part. It's all staying together. It's moving around just fine, exactly as we wanted it to. And that is a universal joint. Thank you for watching.